One final concept I want to mention briefly, because it comes up in your textbook and will show up in a few places, is the idea of the standard deviation of the mean. And this is a little bit different than a regular standard deviation. And is calculated differently, of course. What this is a way of measuring how far your measured mean, so x bar, so how far is x bar from mu, from the population mean? All right, and so as you do more and more measurements, this number will get smaller and smaller. So sigma n, which is the standard deviation of the mean, is equal to sigma divided by the square root of n. All right, and so this is the way to calculate this standard deviation of the mean. So a regular standard deviation, or S, that's this formula here with the square roots and the sums, x bar xi minus x bar squared divided by n minus 1. This, as we increase the number of measurements, so as we increase n, this number will approach sigma, which is the population standard deviation. Right, so this value will ideally get smaller and then approach a single value, and as you add more measurements, this number won't change. It's just going to be a constant. What's different with sigma n is that you can see from the formula that as n increases, right, as this number gets bigger, as we increase n, eventually this number will approach 0. So it doesn't approach a constant, it approaches 0. So basically this is a way of saying that as you keep measuring more and more values, your standard deviation of your mean value will get closer and closer to whatever the actual value of mu is. Whatever the population standard deviation is.